Hello student, let's solve the question number 5. Two short dipoles are placed at a certain distance, exert a force F on each other. If distance between them is doubled, then the force will become. Okay, so here we have two dipoles. They are placed at a certain distance. Uh, so suppose here is a dipole P1 whose dipole moment is P1 and they are separated at a distance some distance. So suppose here is another dipole of dipole moment P2. Okay, so what is the distance between them? Let this is the center of the dipole P1, this is the center of the dipole P2, and let R be the distance between them. So the force which is being acted in between them is F proportional to 1 by R to the power 4. Okay. So from this relation we can easily get the new force between them. Suppose the new force is F prime and the previous force as given in question is F. So it will be as here F is proportional to 1 by R to the power 4. So the new R prime, so here F prime, so here the new distance is 2R, right, whole to the power 4, and the previous distance was R, so here R to the power 4. And from this we can easily get that the value 2 to the power 4, the value of 2 to the power 4 is 16. So from here we get F prime is equal to F by 16. So we can easily tick the answer that option 4 is correct. But it's better to see how we get the relation F proportional to 1 by R to the power 4, right? So see, we have to find the force between them, right? So before that, let's write the value of electric field at the position of P2 due to P1. What is the value of the electric field at the position of P2 due to P1? Nothing but 1 by 4 pi epsilon naught. Okay, 2 P1 by R cube, where R is the distance between them. Now we will write the expression for potential energy of this two dipole system. The potential energy is nothing but negative sign. The dipole P2 is situated at this point, right, where the electric field is written. Okay, the potential energy of the system will be P2 with dot product this electric field E1. This electric field, just I write it as E. Okay, so what will it will become, you see, minus 1 by 4 pi epsilon naught 2 P1 dot product, the direction of the P2 and E is in the same direction, so they will just add. So I will not write the vector sign anymore. So P1 P2 by R cube, right? So this is the potential energy in between them. Now I would like to get the force which is in between them, the dipoles, right? So the force F is equals to, we can write the expression of or the relation between force and potential energy as F is equal to minus del U del R. It is nothing but the partial derivative of potential energy with respect to the position vector R, right? Okay, so here we have U and now we have to derivative. We have to do derivative with respect to R, right? See, this part is completely a constant, right? So here a negative sign, here a negative sign, they will cancel each other. And finally the constant will remain 2p1 p2 by 4 pi epsilon naught, and then and then del r of 1 by r cube, right? Del r of 1 by r cube. What is the value of this derivative? Is nothing but minus 3 will be multiplied with this, so we'll have minus 6 p1 p2 by 4 pi epsilon naught, and 1 by r cube will become 1 by r to the power 4. So from this we can write that the force is proportional to 1 by r to the power 4, right? So this is the derivation of the relation, but we need to remember the relation F proportional to 1 by r to the power 4, the force between two dipoles situated at a distance r. Okay.